Alright, so we're back, and we'll be continuing with flowcharts. Remember, once again, any questions, concerns, comments, anything, let me know. Flowcharts now. So flowcharts are algorithms that use symbols to depict the input, processing, output of data and information. These symbols, they use the same terms to illustrate the flow of data that you would use in pseudocode. So the same keywords, input, output, the processing and so on, the if and the loop and so on, it is still the same statements apply for your flowchart, but just that we use the symbols here to represent the statements. So we have the very first symbol called the Terminator symbol. This is used to identify the starting point and the ending point of your flowchart. So as you can see in this example here, we have the Terminator at the starting and ending point of our flowchart here. So kind of like an oval. Now, for a parallelogram, we're basically using that for input and output. So that is what indicates our input and output. So if we look at the example here, so input, so we input number 1, number 2, number 3, and here we have our output. So this symbol here represents input and output. 3, our rectangle is for process, and remember, process is basically a calculation. So any form of calculation is being carried out inside of our process. So if we look back at our example, so notice our addition here of adding 1, 2, and 3. They're inside of a rectangle there, the process symbol. Now next we have the diamond symbol. The diamond symbol is used for the conditional statement. So remember, we just learned about conditional statement. We learned about the if then and the if then else. So they are placed inside of the diamond symbol. That's called the decision symbol. Next we have the connector symbol. The connector symbol is when you are going to link to an external element or detail not included in the flowchart. Remember, we talked about earlier that you can make your program modular. You can use subroutine to basically break up your program. So if multiple persons made multiple parts of the flowchart, we can use the connector symbol to indicate that this flowchart can be connected to another flowchart. Basically, we're going to show you examples of them. And then the flow lines, they show you the direction of the data flow, where the data is flowing. Now each symbol represents an action or condition, and within most symbols, text is used to describe what is happening, while the arrow indicates the flow of data. Some rules of flowchart include: every flowchart must have a start and a stop, just like your pseudocode. The start and stop symbols are called terminals or terminators. The arrowhead of the flow lines indicates the flow of direction. The main symbol used in flowchart is a decision, which is used for selection, which is the if, and the process, which is used for your calculations and so on. Now the flow of sequence is generally from top of the page to bottom. So whenever you see a flowchart, you're looking at the symbols from top to bottom. However, this can vary. Sometimes there are loops which can basically loop back up to the top, which need to flow back to the process or decision. So you might see a line with an arrow pointed back up to the top. It's just for you to follow the lines with the arrows. It's that simple. Now next, there are also some important rules for the symbols. These rules also generally apply to algorithms and pseudocodes. So processes have only one entry point and one exit point. A process symbol has only one entry and one exit. So remember, this rectangle here is your process symbol. It has one entry, one exit point. The lines with the arrowheads indicates the flow of sequence, the flow of data. Decision is going to have one entry, but it's going to have the true and the false exit points. Because remember, the decision is the if then and the if then else. So if there's a then obviously is only one output. So for example, one input, one output. But if it's the if then else, we can have one input with two outputs, one for the true and one for the false. Now, next we have the repeat loop, the while loop, the for loop. All of the loops that you would have learned so far can be applied into this flowchart also. So the repeat loop has a process before the decision. That is, the repeat loop will always execute at least once. That's what we learned already, right? The repeat loop repeats at least, runs at least once. And the while loop is generally reverse. The decision comes first, or the condition comes first, and then followed by the process, all of these statements. The while loop is usually drawn so that it loops while the condition is true, and the repeat loop repeats until the condition is true. You can ignore this, just try to remember what we covered so far about the differences before that confuses you. So it's important that you practice drawing flowcharts since they illustrate the orderly flow of data in algorithm. If a flowchart is not created properly, it can cause confusion, result in a statement that is not logical, or produce incorrect information. You should first practice drawing the symbols and then draw some of the sample flowcharts and so on. So you gotta ensure you draw the symbols correctly, because as you can see here, you could accidentally draw the process symbol for the input and output symbol. Now, sequence statements, similar to pseudocode, where a set of statements are executed one after the other from the first statement to the last. Flowchart also depicts the sequence statements using symbols. So it goes in a sequence that you see the flow lines go in. Flowchart has a start and a stop symbol. There are also small circles called the connector symbols that indicate the flowchart is part of a larger one. Remember we talked about the subroutine, the modular flowchart. So the connector symbols indicate that's just a part of the flowchart. Sequential statements, they are joined by directional arrows because you got to indicate from what sequence to what. And each symbol has an arrow pointing to it and another arrow pointing away. So one arrow pointing to it and another arrow pointing away to show the direction. And then you have text inside of it that's explaining what is being done inside of the diagram. Now, just like your pseudocode, you could create an Ipo chart to follow along with the flowchart, to create the flowchart. So at the very beginning, you have your Terminator symbol that's indicating start. The second step, you have your input with your input diagram. 3, you have your process, you're adding these numbers together. And 4, you have your output using the output symbol. And then lastly, you have your stop, because you must indicate start and stop. So now you know that the flowchart would have ended here. Remember any questions? Let me know. The flowchart shows a sequence of symbols from the start symbol to the input symbol, process symbol, and so on. The text within each symbol is similar to the Ipo chart example in the pseudocode. So if you notice, the flowchart is a bit more summarized. It can even get more summarized because the symbol represents what it is doing, so you just got to put the necessary variables inside of it and the action. Like for instance, this example here, we input max and min temperature, we calculate it, we calculate average, and then we output the average temperature. Now, how do you implement the conditional statements? We already know how the conditional statements work. If is the condition, then it's true, else is false. So here we have the general structure of the if-then. So remember, this is a connector symbol indicating it is part of a larger flowchart. Here we have our Boolean condition, which is our if statement. This is our condition. If you notice, it's in a process diagram. It's in a process shape. So because your condition, which is your more than, your less than, your equal to, they're all calculations. They're relational calculations. They're checking to see if something, how related it is to another value. So in this case here, if it is equal, less than, and so on. So if it is true, so it would indicate where is the true and where is the false. So if it is true, we go down here, the true part. But then if it is not true, because remember this is the if then, doesn't look at false. If it is not true, then basically we go past the if then, the true statement. Now we're gonna ignore that. So we have an example here. So start, this is our start symbol. This is our process symbol. So if you notice, this is actually initializing. Remember we learned about initializing earlier. So we're initializing this year to 2019. Then we have an input. We input a value into birth year. We input 2000. Now we're going to have a calculation, which is basically a process. We're going to subtract 2000 from 2019, which is going to give us 19. 19 is going to be stored in here. Now 19 is going to reach here. It's going to be asked, is 19 less than 13? Is it? No. So we come down. So we carry out this action here. Student is a teenager. Now if it was true, say for instance it was 12 and it was true, that means we come out here, come down, and we go here, and we go to the end. So that means we would have ignored this here. Flowchart is simple. You're basically following the line, but you just got to remember what the symbols represent. What do they do? Another example, you start, you input a mark, you put in 60. It comes here now. Is 60 greater than 80? No. That means you follow the line, end of the program. That's simple. Now, if it was greater, 90, true. So that's true. We come down, yes. We output, excellent result. We go to the next one. Output, please see your teacher. Then we stop. We're just simply following this, the lines and what action is inside of the symbol. Now if then else, we know that then is true once again, else is false. Condition is your test. So here we have the general structure now. So if you notice now we have a true output and a false output. So this is our test here. We're testing, we're running if it's less than, more than, equal to, whatever the case. So come out to true, or true statement, or false statement. So let's look at an example. We start, we input three numbers, we add the three numbers together. So say for instance we get 30. Now is 30 greater than 50? No. We come out to the left, we print the sum is less than 50, and then we end the pseudocode, end the flowchart. Now the total is greater than 50, it's 60, true. We come out, yes. We print the total, we're going to see 60 on the screen, and we go to the end of the flowchart. Remember, if you have any questions, need any clarification, let me know. A nested condition, we already looked at this here. It's basically combining two or more conditional structures inside of the statements. So remember we looked at putting an if within an if. So as you can see here, we have an if, and you have another if inside of it. So basically we covered already. So another example, start, we input this year and birth year, we calculate the age. Remember, rectangle is process, this is input, this is process, and this is decision. Diamond is decision. So we carry out the decision now. Is the age less than 13? Is 12 less than 13? Yes. We output not a teen. But if it was 14, no, it is not less than 13. We come out, no, he is a teen. So now, this here is an example of a conditional if statement in your flowchart. So if you notice, you have two decisions, decision 1 and decision 2. So basically, it's one decision after the other. And that's simply what it is inside of your pseudocode. It's one if statement after another, or one if statement within another. So we start, we have our inputs, we input a mark, we input 60. Now is 60 greater than 80? Yes. So that means we come down. We output excellent results. We come down again. We output please see your teacher. We go across here now, and we output please await the end of term report, and we end the pseudocode. Simple, that's following lines. Now, but the hardest part might actually be creating one. So if it is, the mark is 60 now. Is 60 greater than 80? No. We come across. Is 60 greater than 70? No. We come down. And then we go here now. Please await the end of term report. But if it was greater than 70, you come down here, output satisfactory results, and then you output please await the end of term report. So if you notice, it's very simple to follow, but all you got to remember is what the symbols represent. That's the important point. The oval is basically start and stop. The parallelogram is input and output. Rectangle is process. Diamond is decision. A circle is a connector. And your line tells you where the data is flowing. Loops now. How do the loops work now? So the same concept from before, your while, your repeat, and your for loop, they all work the same way, but it's how do we design it now in our pseudocode. So here we have the while loop, here we have the repeat loop. Remember the same structure. Remember the while loop has the test at the beginning. While has a test at the beginning. So if we look at the information, while loop, decision is basically the test. It has it as the beginning. The repeat loop has the test at the end. So that's what you're seeing here. And if it is true, you enter the loop. If it is false, you exit. And for the repeat, if it is true, you come out. And if it is false, you repeat the loop. So you just got to follow the lines and remember where they are going. Good. So let's look at an example now. So start, the number is equal to 1. The variable number is equal to 1. Is 1 less than 3? Yes. So we come down. Number equal number plus 1. So if you notice here, we are updating. So the same principles apply. We have to update the variable. So it's now 2. We output number. Number is 2. We follow the line and we go back up. Is 2 less than? Yes, it is. And we keep going all the time. Eventually, we're going to reach the 4. Is 4 less than equal to 3? No. So we come out there and then we stop the pseudocode. Stop the flowchart there. Remember, any questions? Any part needs to be repeated? Let me know. You start once again a variable is initialized with 1, you carry out a decision, not a decision, a process. You're adding 1 to 1, that's going to be 2 here. So we come down, because remember we got to follow the arrows. We output it, we got 2. So this is a repeat, because notice the decision is at the end. So if you notice, it actually doesn't tell you if it is repeat or while. You got to remember that once the test is at the end, it is a repeat. Once the test is at the beginning, it's a while. So we come here now. Is 2 equal to 3? No, we go back up, we do the same increment, we're going to get 3 now. Is 3 equal to 3? Yes, and we come out of the loop. That's simple. Another example. So we start the flowchart. We initialize a variable with a process symbol. Remember, this is a Terminator symbol. Another process symbol, count equal to 1. Then we reach the decision symbol. Is count an even number? Count is not, so that is false. We come out here and we come down. Follow the arrows. Count equal count plus 1. So count is 1 at the top here. Count is now 1 plus 1. That is 2. We come down. Is count greater than 6? False. So we come across, we go back up, all the way back up. We're back here. I'm going to write 2 here so that I remember that it was updated to 2. So we come down. Is count an even number? Yes, because it's now 2. So we do sum plus count, so that's going to be 2 here. Then we come down back here, we increment count. That's going to be 2 plus 1. We're now going to get 3. And then we come back down again. Is 3 greater than 6? And then we go back up and we keep repeating all the time. Eventually we might reach 7. Is 7 greater than 6? True. So we come down and we display whatever is inside of sum, and then we stop our pseudocode flowchart there. So pseudocode may appear quite simple, but by comparison to flowchart. So why would you want to use a flowchart now? The main reason for flowchart is easier to read, because if you notice, it's just following those arrows, and the boxes, basically the diagrams, simply tell you what to do. It's more closely followed. It more closely follows the standard using symbols, unlike pseudocode, and it lends itself more readily to conditional and control program structures. So that's why persons would make use of it. As we continue to practice drawing flowchart, remember these key points. Every flowchart must have a start and end point, just like in pseudocode. The process symbol can be anything from calculation to describing an action. It is represented by a rectangle. So anything that deals with calculation goes into the process. If there is a question or condition or a test, it is going in the decision symbol. And the connection of what symbols follows next is shown with the arrow. That shows you the direction of the data flow. Alright, any questions, concerns, comments? Are we following so far?
Yes, sir.
Alright. This is basically about our operators, and then testing, and that's it for problem solving. Alright, so we got 2 more chapters to complete. Alright, so let's begin. Now, arithmetic, relational, and logical operators. So your operators are what are carrying out certain actions, your processes inside of your pseudocode, your program, and so on. So in many examples in this chapter, you may have seen fragments of the pseudocode. You might have seen less than, and this less than that. So these conditions are evaluated in the ALU of the CPU. So remember, the ALU deals with all calculations. So they handle all of these operations. So arithmetic operation, we should know these here already. The plus sign for addition, minus sign for subtraction, asterisk for multiplication, forward slash for division. Remember I was telling you about mod, modulus. It gives you the remainder of a result. It's like when you're dividing, we know when we divide in, sometimes we get a number with a decimal place. So it gives you the remainder. And then we have div. It's a integer division, produces only the whole number. So it doesn't give you the decimal place. Relational operators, these are used to compare two values together or more. They're basically used to compare. So you will see this operator's algorithm where there's a condition. We mostly use it for conditions because we mostly test to see if something is greater than, less than, and it's usually a Boolean type of answer, a true or false answer. So equal, more than, less than, greater than, equal to, not equal to, those are all relational operators. Next we have logical operators. Logical operators, the conditional, while, repeat, for statements compare values in order to determine a value. For example, while number is less than 3, if mark is equal to -1, if age is less than 13, must each produce a result that it is true or false. That is, when the two values are compared, these operators, the result is either true or false. So logical, it seems as though it's combining the relational and giving you true or false answers. Good. Next we have the not operator. The result of the condition has two options, so true or false, yes or no, accept or not accept, 1 or 0. That means a result is not true, then it is false. If it is not 1, then it has to be 0. So the following tables use examples to illustrate not, and or. This is called the truth table. Let me see if they have that table. Not seeing that table. I don't think this is all that necessary. I don't see it that much in the exam. Let's see. But basically, a not operator, think of it as the opposite. So, like, if today is not Sunday, then it's any other day but Sunday. And as they were saying here, if it is not 1, then it is 0. If it is not true, then it has to be false. If it is not on, it has to be false, off. That's basically the not operator. Has two options, and it's either one or the other, nothing else. Oh, this is what I was looking for. I wasn't finding it. The AND operator. Now, the AND operator, it's when you combine, you check in values, and both values are going to be true. So if the value of one condition is true, then the value of the next condition is true, then the result is going to be true. So this one here has 3. Oh, this one is making use of more. These operators are basically used when you're running various tests, and based on the condition, based on the decision, you get a particular result. But the main takeaway from this AND operator is that all of the values must be true for the final output to be true. If it has any false inside of it, everything else is going to be false. Like for example, this one here. Everything is true, so this is basically true. The person got promoted. But because it has a false here, it has a false here, it has a false here, everything here basically becomes a false. So that's the main takeaway there. Everything has to be true in order for the final output to be true in a AND operator. In an OR operator, everything has to be false for it to be false. Everything has to be false for it to be false. So if you notice, everything is true here, but the answer is true. We have one false here, a true here, but the answer is still true. We have a true and false here, the answer is still true. But the only way you get all false in a OR operator is that everything has to be false. It's just for you to remember that pattern there. Condition of combination of operators. So how do they make use of these operators now? So let's just look at an example here. So if mark is greater than 70, so if somebody's mark is greater than 70, so say the person got 80, and at the same time, so both got to be true at the same time, and at the same time the person is in the third term, then we display promoted. So that's what's meant here, that everything has to be true in order for the output to be true. So this person here has to be greater than 70 and in the third term to be true. So if the mark was actually 60, then this one would have been false, this one would have been true, and remember, both has to be true in order to carry out then. So one is actually false, so the total output would have been a false. Now for the OR now, in this example here, basically either one has to be true. Either one could be true, and then you're going to get a true here. So it's a bit technical. We have a true here, we have a true here, we have a true, and anytime you get a true, the final output is going to be a true. But when everything is false, that is when it's going to be completely false. So when do we carry out this then part here? We carry it out if this one is true, or this one is true, or both is true, doesn't really matter. So if the mark is greater than 70, if it was 60 and say yes, the rank is 9, then we would have carried out this here because one of it was true. So even if this one's false, this one's true, we still carry out the then because at least one was true. So that's how we use the OR there. At least one has to be true. If there was one was 80 and over here was 11, this one was true, this one was false, and we still carry out the then. But if both were false now, both of them, this one is 60, so it is false, that one is 11, so it is false, we ignore this then part here because it's completely false now. And then here they're combining multiple operators, multiple of that logic operator. So if it is greater than 70, if mark is if that 80 is greater than 70, and the person's in the third term, and their rank is less than 10, only then everything is going to be true. Because remember, and everything has to be true for the final outcome to be true. In the OR, just one has to be true in order for the final outcome to be true. So either one, as we mentioned already. Good. So that's basically how they use the logical operators there. Any questions? Anything you need me to clarify?
No, sir.
Alright, so we basically look at how we carry out calculations there. Um, so testing the algorithm now. So we've come a long way with this algorithm here, where we already went through how to design the algorithm and all parts of it. But now when we're finished with designing the algorithm, we need to test the algorithm. Now, desk checking is the process of reviewing an algorithm for the correct process or output. Desk checking, you're checking to make sure the algorithm functions how you want it to function. You do this by manually executing the steps in the algorithm. You do it manually. You take a spreadsheet, you take a piece of paper and a pen, and you do everything manually. You put in the necessary values and you track the changes along each step. That's why it's important for you to number the steps of your algorithm so that you can trace it. This is basically also called your trace table. Your trace table, this is what you use to test your algorithm. So we started desk checking with example 12 by going through each loop and explaining it. The logic of your algorithm is an important part of testing. Using a trace table will help you to test and verify your algorithm. An algorithm is a series of steps, sequence of steps, which to seek to solve a problem. If you freeze the algorithm at any point and have a snapshot of that state of all the variables, so basically, to test your algorithm is like if you can freeze the algorithm at any point in time and all the variables and all the values, you should be able to tell what value they have at that time where you freeze it. That's the purpose of the trace table. So if you freeze it at line number 2, you should be able to tell what's the value of all the variables if they're going correctly. Now the trace table is a useful tool which allows you to see the state of your algorithm with much detail as you wish. Each row of the table shows the state of each one step in the algorithm. Each column shows the value of the variable at that step. So this here is an example of, this here is a pseudocode at the top here, or a program you can say, an algorithm, and here is your trace table. Now we're going to number each step. So this is step number 1, step number 2, step number 3, step number 4, and if you notice, this is an end and this is a print. So if you notice, each step actually makes up a column now in this trace table here. Each step makes up a column. And what, if you notice what's happening, they're taking the variable from that step and using it as the heading. Why? Because we are tracing that variable. So the quantity variable, that's what we're seeing here, the sold variable, the invoice variable, and then the value variable. So at the very first step, when they have inputs, when they have read quantity, that means to input. So at the very first step, 4 is going to be input. And what this indicates here is that throughout step 1, 2, 3, and 4, step 1, 2, 3, and 4, quantity is going to remain as the value 4. So that's why they brought down the value 4. So that, say for instance, if at any point in time it does change, like say at this very end here, it does change to 5, it would have been indicated like that. To indicate it at the fourth line here, it was changed to 5. Alright, so let me see what is happening here now. So now they enter the for loop. Now the for loop tells you that sold must go from 1 to 4, because notice here it's going from 1 to 4, so you got to loop 4 times. You can therefore fill the column labeled sold with the number 1, 2, 3, and 4, because this variable here, sold, has to go 1, 2, 3, 4. So That's why you see it increment like this here, because throughout each loop, okay, so this is basically each loop. Loop number 1, loop number 2, loop number 3, loop number 4. And quantity is going to remain the same, 4 within each loop. And this is loop number 1, 2, 3, and 4 here. That's indicated there. Now, the next step is to perform 2 calculations within the loop. So, as you see here, we're minusing sold from 4 and storing it inside invoice. So, when sold is 1, invoice is equal to 4 minus 1. So, sold at the very first stage is 1. At the very first loop is going to be 1. So, that is why it is 4 minus 1. And we're going to get 3. So now 3 is going to be stored inside of INV. So that's why you see 3 here. Now the next step, we're going to write the number 3 under INV. And we go to the next calculation inside of the loop. The number 3 can now be used in the second calculation. So the second calculation is INV minus sold. So we just calculated INV is going to be 3. So that's going to be 3 minus 1, which is equal to 2. So 2 now is going to be stored in, or times 5. So 2 times 5, so that's going to be 10. And 10 now is going to be stored inside of value. Did I calculate something wrong? Let me see. So, oh, I didn't carry out bod mass. Oh, that was my mistake there. So bod mass is important. So the brackets, order, division, multiplication, addition, and so on. So therefore, 5 times 3 is going to be carried out. So that's going to be 15. So 1 minus from 15, that's going to give you your 14. And we basically repeat that. We continue to repeat that. And that's how you trace your pseudocode. So they're going to continue once again. When sold is now 2, so we're now at the second loop. It's going to be INV equal 4 minus 2, so 2 is going to go here, and then the val calculation, and 8 is going to go over here. So as you can see here, so a trace table, you're basically one row is going to be tracing basically what one loop of the of that program, of that trace table, of that that flowchart or algorithm, and you basically carry out the calculation and you put in the necessary value. Any questions? Anything you need me to clarify on the trace table?
No, sir.
Alright. Well, I guess that brings us to the end of problem solving there. The programming parts, we're going to continue that at another time. Maybe later today or tomorrow, we can see what happens there. So, we're going to close off here for today. If any questions, concerns, suggestions, let me know. Otherwise, we shall end here for today.